So today I'm going to show you how to do what we call combining like terms when we're solving an equation. So if we are going to solve a one or a two-step equation by combining like terms, think about the word combining as putting together or adding. Like terms, like we've talked about already, your terms could be like 5a. We could add those to the other a's. Another term of your equation could be the constant, like 13. So if I had 5a plus 13 equals 40, 5a and 13 are both terms. We could not add those together because we don't know what a is worth. So let me show you with a couple of examples to help you out. So if I have 7x minus 4x equals 21, that means some number times 7, and then that number times 4, the product of those two, we would subtract and take away 21. So instead of sitting here and trying to guess and check what those answers might be, what we want to look at is combining those things that are together. So we are going to combine the 7x and the negative 4x. Now you can think about this visually. If you have 7 x's, you could take away 4 x's. That would give you 3x. So again, if you had 7 x's, 1, 2, 3, 4, 5, 6, 7 x's, and you took away 4, subtracting means taking away, 2, 3, 4, you could see that we'd have 3 x's left. Another way to think about it, these coefficients, a positive 7 combined with a negative 4, signs are opposite, so you subtract. 7 minus 4 is 3, and there's more positive, so that's another reason why it's positive 3. So a couple ways that we're going to show you that. So now what we've done is we've made this a one-step equation. So 3 x's are sharing 21 positives, but we want to know what 1 x is worth. So 3 next to the x means multiply, so we're going to do the inverse, that means the opposite operation. So the opposite of the multiply by 3 is to divide, and your coefficient is just that number working with the variable. So if I divide both sides by 3, 3 divided by 3 is 1. And another reason why you can think about that is if you had 3 x's over here, and you wanted to put it into 3 equal groups, well, 1, 2, 3 groups, because you need 1 x by itself. And 21 divided by 3 is 7. So we have a prediction that x equals 7. But we can prove that. And I always want to make sure that y'all know that you can double check your work. So I'm going to check it out over here. Start with your original equation. 7x minus 4x equals 21. So we're going to take that 7 wherever we see the x in the original equation, and we're going to substitute. So 7 times 7 minus 4 times 7. Again, we are just taking where we saw that value of x, and now we said that we feel like it's 7 after we combine those like terms. So there are parentheses, but there's the grouping symbols, but there's no math to do in them. There's no exponents, but there is multiply and divide from left to right. 7 times 7 is 49, and we can bring down the 4 and the 7 in the parentheses. Do one step at a time so we don't overwhelm ourselves. Now we can't subtract yet. We can't say 49 minus 4 because there's still multiplication. So always do multiply and divide from left to right. So we can bring down that 49. 4 times 7 is 28. And as long as 49 minus 28 is equal to 21, 9 minus 8 is 1, 4 minus 2, yep, it checks out. So the one and only one value that we could have substituted here for x to make this equation balanced, to make it a true statement, 21 equal to 21, was 7. No other value for this equation would work, so x is going to be equal to 7. Okay, so let's try another one to help you guys out. And we're going to use more of this on our next assignment as well. So we have 5z combined with 4z's. So again, if you like to think about a picture, if you have 5z's, 1, 2, 3, 4, 5, and you have 4 more, How many z's do you have? Well, hopefully you said there's 9. So basically, when you have these coefficients, that's the operation you're working with, and you're just going to bring that letter. So there's 5 z's combined with 4, so you see 9 total z's. So we combined the like terms, combining the z's. So 9 z's are sharing a total of 36. So if we want the 9 z's not in a group of 36, we want just 1 z. Well, here again you can think about it. We wanted to know just one of these z's is worth. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to divide by 9. So 9z divided by 9. And what I do to one side of the equation, I do to the other to make it balance. So what we see here is 9 divided by 9 cancels out. That should say z, not x. And 36 divided by 9 is 4. So again, we have a prediction that that is going to be 4. But let's prove it with the math. Now, an important thing that I wanted to note up here, we're combining with the same variable raised to the same exponent. So x, these two x's, if they don't have an exponent, that just means to the first power. These z's don't have an exponent, so that's also to the first power. So that's something we want to look for, and we'll keep practicing with that as well. Oh, I forgot to write up here, divide both sides by 9. So again, we want to check our work. So we start with our original equation, 5z plus 4z equals 36. And we're going to substitute where we see the z, we're going to substitute, we said, 4. So 5 groups of 4 plus 4 groups of 4 equals 36. So again, we said z was equal to 4, so that's what we're substituting right here. So 5 groups of 4 is 20. Bring down the 4 groups of 4. So I bring my work over here. So there were parentheses again, but nothing, no operations in math to do for that. No exponents, so we're going to multiply and divide from left to right. So that's why I did that 5 times 4 first. And I brought everything else down. Now I do 4 times 4, which is 16. And 20 plus 16 is 36. So we know that we are correct. That means the one and only one value that I can multiply by 5, and I can multiply by 4, and find the sum of those products together would get me to 36.